Hello and welcome to Real Civil YouTube channel. In this video, I am going to show you how to analyze a truss in the etab software, and we will compare our results with our manual calculated results, in which we will compare support reaction as well as the member forces and are they in tension or compression. All these results we will check. Okay, so let's open the etab. First go to new model. Okay, use built-in setting metric Indian IS 800 2007 and IS 456 2000. So first we will create the grid lines, so it will be very easy for us to model. Okay, so this is 12 meter and the height is, you can see here, 4.5 meter. So I will give the x direction 3 and the spacing will be 6 meter. In y direction there is no need actually, and for z direction it will be 2 and it will be around 4.5. These are just grid lines or like a reference lines. Okay, so we can modify these from this edit grid storage data. Okay, I have opened the elevation here so that we can work easily. First go to the material properties, add new material. Here select India, go to rebar, select mild steel, click on OK. Now go to define. Now we have defined material, now we will define the section. So add new property, you can add anything. Okay, any section you can add here. Okay, so here is auto select list is there. So I will take ISLB. Okay, anything, any material and any section you can take, because we are ignoring the dead load. Okay, so now let's draw this truss. Okay, so we'll start from drop beam. We'll select the beam here. Okay, and this first is here 12 meter. Okay, then similarly we will join this part. Okay, and then we will join this. Okay, so our modeling part has been done. Okay, now we will provide the support condition. Okay, here we will provide a simple support. Okay, now here we will provide the roller support. Just wait. Assign joint restraint. Okay, so here Z is the upward, hence you have to select the Z. Now we have provided the support, we have drawn the beam. Now we will apply the load. So load is here, you can see 9 kilonewton is the point load acting here. So I will select this, assign, I will go to joint load, force. Okay, so before that I will create one case. Okay, so for that we can go to define and go to load case, load pattern. Here you can delete this because we don't want any dead load. Okay, so give any name, like I will giving the point load. Okay, and I will consider it as a super dead. Okay, so I don't want any live load like that. Okay, so now just select this point, go to assign joint load. Now we are applying the load at the joint. So here by default it will come the point load because we have deleted all other cases. So go to global Z and our load is 9 kilonewton in downward direction, hence it is -9. Now apply. Okay, here you can see the 9 kilonewton load has been applied at this point. Okay, these are our truss members. So here there is no any bending moment, only axial forces will be there. Hence first select the entire truss, go to assign, go to frame and go to releases, and here we will release all the moments. Okay, now we have applied the load, we have given support condition, we have assigned the properties. Okay, now we can go for analysis of our truss. So before that you can save this model. It will take some time. Okay, the analysis has been completed. Now we can see the forces support reactions. Okay, tabulated, apply. Okay, so here on the right hand side you can see it is 4.5 and 4.5 on either side, and by manual calculation also we have got the 4.5, and here also we get the 4.5 kilonewton. That means our support reactions are, we have compared. Now let's see the member forces. Okay, so go to display forces. Now here just click on axial forces, click on apply, click on OK. So here you can see 7.5, 7.5, and here it is 6. So here you can see the 7.5 we have matched 6 kilonewton, also we have matched here. Okay, so also you can see these two members are in tension and this member is in compression. Okay, so this is it. We have compared the support reaction and the member forces from our problem. Okay, so we will come with slightly difficult problems also in upcoming videos. Okay, so thanks for watching the video. Please like, share, subscribe the Real Civil YouTube channel. Thank you so much.